Okay, again, some more chapter review. Homework problems. This is number 43, and we finally found an easy one here. And all we have to do is find all the derivatives. Well, this is my function y equals x to the fourth over 2 minus 3 halves x squared minus x. If I take the first derivative, that's one derivative, then that's going to be 4 x to the third over 2 minus 2 times 3 halves x, okay, minus 1. And then we can simplify this as just going to be 2x to the third. These 2's cancel, so 3x and negative 1. So that's the first derivative. Then I can take the second derivative, which is just the derivative of this, which would just be 6x squared minus 3. Then I can take the derivative of this, would be the third derivative, which would be 12x. And I can take the derivative, that would be the fourth derivative, which is 12. And all the rest of them are zeros. So those are your 4 derivatives that you can take. And then number 45, a tangent line and a normal line problem. It says find the tangent normal line to the curve at the indicated point. So this is a little bit on the straightforward side. This is my function y equals the square root of x squared plus 2x. And my point given was x. So I have to find the y, so all I have to do is put this value of x in the original function. So that's going to be 3 squared minus 2 times 3. To evaluate that, that's going to be 9 minus 6, or the square root of 3. So that's my point, 3 square root of 3. And in order to find the slope of the tangent line of that point, what I'll do is I take the derivative and evaluate it at x equals 3. Well, again, we're going to use our good old square root rule. That comes in handy, doesn't it? 1 over 2 times the square root of x squared minus 2x, all times the derivative of what's in here. Using the chain rule, that's 2x minus 2. And if I want to evaluate that to find the slope of the tangent line at 3, I put 3 in here. So every time I see a x, I put a 3. So I got 2 times 3 minus 2 on the top. And 2 times the square root of 3 squared minus 2 times 3. And this is 3 times 2 is 6 minus 2 over 2. And then this was the same as over here, the square root of 3. 9 minus 6 is 3. What's 6 minus 2? 4. What's 4 divided by 2? 2. So I got 2 over the square root of 3. And we can leave it like that. We don't really have to rationalize that. So we got 2 parts. Let's find, first of all, the equation of our tangent line and then our normal line. And we've done these before. This is the tangent line. The slope of the tangent line, MTL, is 2 over the square root of 3. Evaluated at this point, 3 square root of 3. So y minus y1 equals m times x minus x1. Y minus y1 equals m times x minus x1. Okay, no problem. And we can multiply this out. 2 times the square root, 2 over the square root of 3. You don't have to rationalize it, times x. Minus, and then 2 times 3 is 6 over the square root of 3 plus the square root of 3. And if I rationalize this so I can combine it, and you can leave this in various forms, it's just how far you want to simplify. If I rationalize this, I multiply the top and bottom by the square root of 3. So I get 6 over 3, which is 2. So negative 2 squares of 3 plus 1 square root of 3 is a negative square root of 3. So this is your numerical part, and then this is your slope. So this is your intercept part. Okay, so that's your equation of the tangent line. And then if we want the normal line, remember the slope of the normal line is just, because it's perpendicular to the tangent line, is the negative reciprocal. So we just flip this over and put a negative sign. That's our negative reciprocal. Same point. And then we can go through this. And y minus y1, these are the same format. It's just the only thing that changes the slope. And again, we can multiply this out. So we got negative the square root of 3 over 2 times x, which is your slope. And then negative times the negative is positive. 3 squares of 3 over 2. And then I can add this square root of 3 to both sides. And if I put it over common denominator, that's like 2 squares of 3 over 2. 2 over 2 is 1. 3 plus 2 is 5, so it's like 5 squares of 3 over 2. And this is your slope. So that's your equation of the normal line. So that was 45. And I think 47 was the same type of problem, a tangent line problem, or tangent normal line problem. And so let's take a look at this. The only thing is we have to find the slope implicitly. So they actually gave you both points. If they gave you 1 point, you could just put the x value in to find the other point, or to find the other coordinate, excuse me. If they gave you just the x, you'd have to put it in here to find the y. And it should check out. Not any point will check out. It has to be one that makes this true. So we'll take the derivative implicitly to find the slope of the tangent line at this point. You basically just find the slope anywhere. First of all, take the derivative, 2x dx dx, 4y dy dx, and the derivative of 9 is 0. Subtract 2x from both sides. Divide both sides by 4y. And dy dx equals negative 2x divided by 4y. And that's negative and x over 2y. So that's our derivative. And then I want to evaluate that at the point 1, 2. So we just put 1 in here for x and 2 in here for y. So negative 1 over 2 times 2, which is negative 1 over 4. So there's the slope of the tangent line. And we've got our point. Our point was 1, 2. So we'll do this like we did the last problem. We've got two parts, A, B. A is the slope of the equation of the tangent line at this point. So y minus y1, so y minus 2 equals the slope, negative 1/4 x minus 1. And sometimes you could just leave it like that. If it's an open question, you leave it like that. If we were told to solve for y, then we could add 2 to both sides. A negative 1/4 times x is negative 1/4 x, and a negative times a negative is positive. 1/4 times 1 is 1/4. And this is going to be plus 2 if this is from the other side. And 2 is 8/4, so 8/4 plus 1/4 is 9/4, so there's the equation of your tangent line. The slope of the normal line, m of m n l, the slope of the normal line is the negative reciprocal, so negative negative is positive, reciprocal of 1/4 is 4, so there's your slope, there's your point. So y minus y1 equals m times x minus x1, I can multiply, so I get y equals, and this is 4x, negative 4, and if I add 2 to both sides, I get positive 2. Negative 4 plus 2 is negative 2, so there's the equation of your normal line. So those were a little bit easier. Hope that helps.